This lesson is on exponent rules. We're going to start out by multiplying monomials. So we have 2 squared times 2 to the third. You'll notice that both of our exponents are positive whole numbers. We're going to start looking at this by looking at what this means in expanded form. 2 squared means 2 times 2. 2 to the third means 2 times 2 times 2. So when we look at this in expanded form, we see that we have 2 multiplied times itself 5 times. So this gives us 2 to the 5th. We can do the same thing with x squared times x to the 4th. X squared means x times x, and then we're going to multiply that by x to the 4th, which is x times x times x times x. And when we see this written in expanded form, we have x multiplied times itself 6 times is going to be x to the 6th. On this last example here on this page, you notice that we have coefficients for both of our variables. Since this problem is all multiplication, we know it doesn't matter what order we multiply in. And so when I see problems like this, I like to reorder. I like to put the coefficients multiplied times each other and the variables times each other. So I would say 2 times 3 times x cubed times x. X cubed in expanded form is going to look like x times x times x, and then we multiply that times our other x. And when we multiply, we know 2 times 3 is 6, and x times x times x times x is x to the 4th. In these 3 examples, we're doing what we call taking a power to a power. We have a number that's squared, 3 squared, and it's being taken to another exponent, the 5. When we see 3 squared to the 5th, that means since the 5 is outside this set of parentheses, we want to take that whole thing to the 5th. So we're saying 3 squared times itself 5 times. There's 4, there's 5. 3 squared times 3 squared times 3 squared times 3 squared times 3 squared. If we write this out in expanded form, it's 3 times 3 for each of the 3 squareds. And we notice that we have 10 3's, so this is 3 to the 10th. When we look at x to the 4th squared, that means we're going to do x to the 4th times itself. X to the 4th times x to the 4th. Well, x to the 4th, we said, is x times itself 4 times, and then it times another x to the 4th. Gives us x to the 8th. And then the last example we have here is 3x squared cubed. Since this whole thing is in parentheses, all of it is being taken to the 3rd power. So we're going to say 3x squared times 3x squared times 3x squared. We multiplied what was in the parentheses times itself 3 times. Now I'm going to reorder this like I did on the other problem. I'm going to group all of my coefficients together. 3 times 3 times 3. And then we have times x squared times x squared times x squared. Give us a little more space here. And then I'm going to expand my x squareds. We still have 3 times 3 times 3. X squared is x times x. And then we have another x squared, so times x times x. And another x squared, so times x times x. 3 times 3 times 3 is 27. X times x times x times x times x times x is x to the 6th. There are shortcuts for both of these rules on what you do with the exponents, but what is really important for you to see is you can always think about it in expanded form. Often you can write it out in expanded form. Obviously, if the exponents get huge, you don't want to expand x to the 20th. But for the most part, most of the exponents you'll deal with right now are small, and if you'll think about them in expanded form, you won't need to memorize any rules.